Hello everyone, welcome to a new episode of the Windows Store Developer blog series. My name is Christophe and today I will talk about WinRT. But not WinRT for Windows Store application, but for a desktop application. Follow me for this weird journey. During our build episode, I quickly presented my WinMDiff tool that displays the differences between two versions of WinRT. The implementation is using the unmanaged reflection API of .NET to load WinMD files containing the WinRT metadata. This is possible because WinRT is using the same metadata file format as .NET has used for years. So shouldn't this make easier for a .NET desktop application to use a WinRT type? It definitely helps. Like a Windows Store app, a desktop app sees WinRT types as .NET types and the projection layers does the rest. Let's see where the metadata files are stored. To find out, I will be creating a Windows Store app project in Visual Studio and we'll take a look at its reference. Let's go to the reference, take a look at the Windows part, look at the properties, and we have here the folder where the windows.winmd file is stored. Let's take a look at this. And you see, you have the windows.winmd file and the windows.xml file. These two files are stored here when you install the Windows SDK. The WinMD contains the metadata and the XML contains the description, the documentation that is used by Visual Studio and some of my tools to give you some hints about the types and the members. So now what we should try to do is how to do the same with a desktop app. So let's close this project and let's create a desktop project. I want to use the network information part of WinRT in a desktop app. So I will go to Windows, try to use a console app. Yes, it's also working for a console application. It doesn't have to be a GUI application, a Windows Form or a WPF. Let's call it network info. And let's take a look at the references. And if we right click here, try to add references, you will see there is no reference of the Windows. There is no Windows entry. And we need to tweak a little bit the project to allow Visual Studio to let us add a reference to the WinRT API. So it's easy. You unload the project so you can edit it by hand. You do edit and here you have access to the XML definition of the project. And what we need to do is adding a new property group. And in the property group, I will add a new property which is called target platform version. And for this, I will add 8.0 as a platform. And now I'm closing it. I will reload the project. And if I take a look at the references and try to add a reference, now we have a new one, a new entry here on the left, which is called Windows, and the version of Windows is the highest version possible because it's 255 in each version information, and it's just a matter of checking this box, click OK, and now we have referenced Windows as the same way as it was in the Windows Store application. So the next step is adding some code to reference some of the API of WinRT about the network. So what I want to do is using the network information, network information type, and here what is missing is the using. So I do a control dot, and with the control dot I get the automatically the missing using windows.networking.connectivity is adding for me by Visual Studio. So what I will do, I will add I want to be notified when something happens in the network, when I get a new connection, if I'm losing my connection, I want to be notified. So for that, I'm using the network status change, and I will add a new handler for that. And I will take a look at what we will add here. I want to display the basic information of the network, and I'm only interested in the connected connection. So I will write a tiny static method, which is, let's say, dump connection profiles, because in WinRT all the connections are seen as connection profiles. And what I will do the same when my application starts at the beginning. And I will do console.writeLine explaining that we need to press enter to end the application. And we wait. Console.readLine. So that's where we can very easily end the application. So in the dump connection profile, I will keep on using the network information. As you've seen, it's automatically recognized by Visual Studio as .NET type. You get auto-completion, you get the documentation, everything. And so what we will do now, we will just iterate on the connection profile. So let's say for each profile in network information dot get connection profile. And for these profiles, what we will do, we will check if the connectivity level profile dot get network connectivity level is it's different from none, because we want any kind of connection, the constraint, the internet connection, and the local access. So if it's not none, then we will get more detail about that. I'm only interested in connected connection, because here, if you list all the connection, you will also list the connection that you've used in hotel or in different places, and you are not interested in it. Just for this sample, I want the connected one. So I will use a boolean is connected equal true, equal false, sorry, because by default I don't have any connection. And so at the end, if there is no connection, if not is connected, I will just show a message saying that there is no connection variable. Okay, so what I want to get for a connection is I can get a few information. I can get the profile name. I can also get the profile dot get network connectivity level. So we'll figure out if it's a local and all that stuff. I can format a little bit more than that. So I will show the name first, and then the connectivity level in second. Okay, what else do I need? I will need maybe the network ID, just the network ID. Profile dot network work item network adapter, and from the network adapter I will get the ID of the network item. So I will get the ID of the network. That's fine. What did I miss here? The best overload method is the best overload method match for while string some invalid arguments. Yes, I just forgot to use this other method instead of a property. And now what we have here is a tiny console application that references WinRT to display the connection information on my machine. What is missing is when I'm changing the status of my connection, then I will get notified and I will do the same. I will dump my connection. Very simple. So let's try to compile this. And you will see this is where we start to get a little bit of problem. So what do we have? We have a few errors. Let's show what's the problem if I'm clicking here. So here for the event, the property indexer or event Windows blah 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 network change is not supported by the language. Try directly accessing accessor methods blah blah blah, which is the add handler for the event. Okay, then you get blah blah blah. This is what you need to do. And the other one is a little bit more explicit for us, is the system.collections.generic.I read-only list of T is defined in an assembly that is not referenced. You must add a reference to assembly system.runtime. So here we have the solution with the compiler error. So let's try to add this reference. Add system. Whoops, sorry, I just forgot the name. System.runtime. So add a reference. Let's go to assemblies and let's see if we have system.runtime. System.runtime. And we don't have system or runtime. So we need to figure out where this is stored. This system.runtime assembly is provided by the Windows SDK and by Visual Studio when you install it. And it's in a folder. This is the folder, assembly, Microsoft Framework, .NET Framework, version 4.5 and the facet. And we'll take a look at the system.runtime. Here is it. So if we use this as a reference, so in the browse, we go to the folder and we just add the system.runtime. Okay, and we try to compile, and we still get this this issue with the property indexer and with part of the projection done by the compiler. And what we need to do is adding another reference to another assembly, which is the system.runtime.interruptservices.windowsruntime.dll. Again, it's in the same folder, so it's the system.runtime.interruptservices.windowsruntime. Here is it. So add this one, do OK, compile, and here it is. We have a .NET desktop application, a console application that compiles. So now let's see if we can make it work. So we just run it. And you see here on my machine, I have an internet local access with the ID. And again, I don't have any connection available. So there is a problem with my code. So I hope that some of you have seen the tiny bug I've left. If you take a look at this, I didn't change the value of connected. So I need to change the value of is connected to true when I find one of the connection. So Control F5, and here it's perfect. I have the internet local access. Okay, simple. This is a good first example. Maybe I could demonstrate that the event is really working. So let's remove the network. I will just remove my connection here. And I'm expecting, you see, no connection available. So that's good. The event is also working. I have just shown how to use properties, methods, and events of a WinRT type in a desktop console app. As you might guess, all is not that shiny, because it is not possible to use each and every WinRT type in a desktop app. For example, it would be great to have a desktop application share data through the Share API. Unfortunately, the Data Transfer Manager type of WinRT is not usable from a desktop app. But the clipboard is, by the way. So how can you figure out which type you can use? The first answer is very simple. Go to the documentation. If you go to MSDN and take a look at the types, so here is the documentation for the Data Transfer Manager class, and at the very end of the page, you see the requirements here. And here we have the requirement for the minimum supported client and supported server, and as you can see here, we have the Windows Store app only, same for the server, which is good, because it means that this type, you are warned that you can only use it in a Windows Store app, no desktop app. If you want to use it in a desktop app, well, you will get some exceptions at runtime, because it will compile, because Visual Studio will see it as a .NET type, and it has all the metadata, so it will be able to code and write your code and compile it, but when you execute it, it will fail with some exceptions. If you really want to know all the types instead of checking type by type, you can use one of the tools I've provided in my blog. And the tool is called Dual API Finder, and it lists the WinRT types that are usable by desktop apps. Long story short, it's using the same .NET Reflection API to load the WinMD file, and it will take a look at a tiny attribute, which is the dual API partition attribute here. And for each type decorated with this attribute, the tool knows that this type is used by both Windows Store application and desktop application. So when you start the tool, you select where the WinMD file is. You remember this is the folder where I have shown you before where the windows.winmd file is, and when you click on the go, you will get the list of all the types, and you can see here that the windows.application model.data transfer and the clipboard is available for a desktop application, which is cool, because Windows Store application can add more information to the clipboard than the usual Win32 clipboard API. So you have two solutions to get information about the API you want to use. You have this tool to get a quick view, and you also get the MSDN documentation. Go at the bottom of the page, take a look at the requirements section, and ensure that here you will see the Windows Store app and the Windows Desktop application. So if we take a look at the, let's take an example. It's the data transfer. And if we have the data transfer, MSDN, and data transfer.clipboard, and we'll take a look at the type. So we have the clipboard. Sorry for the French translation. Let's go to the English one, and if we go at the bottom of the page, you will see that we are lucky for this one, because you have both desktop apps and Windows Store apps. Unfortunately, you cannot 100% rely on the MSDN documentation or my tool to figure out when you can call a method on a WinRT type in a desktop app. I'll take 3 APIs to show you the kind of issues you might end up with. I've written a small WPF application to do my demo because I don't want you to waste your precious time watching me typing. Before going into the API detail, I should mention that you need to add a reference to another assembly from the GAC in order to be able to await on a WinRT async operation, and the assembly is the system.runtime.windows runtime. So let's take a look at my application. I just mentioned the references. So what you need to reference is this one, the system.runtime.windows runtime, and we'll see in the source code where it's needed in the await. So my application is very simple. I have 3 different buttons, one for each API I want to demonstrate. And if you take a look at the source code, I have my button handlers, click handlers here. So the first one is to show you that some types, like application data, they are supposed to be used by a desktop app, but an exception is thrown when you try to get the current instance for the desktop app. And that makes perfect sense because a desktop app is not recognized by the system as having the usual Windows Store app, local and roaming dedicated folders. But it's a little bit frustrating when you expect to be able to use this type, but you get an exception here. The second one is the type which is called user information, from which you can change the picture of the user on Windows 8, and you can also get and set the name of the user. And this one is also supposed to be used, but what it's changed compared to the previous type is the fact that the type exposes properties to let you know if you can use it to change the picture account. So is it enabled or not? Can you do it or not? And same to access the name of the current user. And if you run this, so I will run this, put a breakpoint here. I will run the application. It's a small one. I'm clicking on the user information, and here you will see in the trace that it's false. So it means that you are not able to change the account picture. And if you are calling the name access allowed property, you will see that the result is also false. So what does it mean? It means that almost all method or property you would like to use will either return nothing or trigger an exception. For example, the user information get display name async, for which you want to await because it's an asynchronous call. This one will run, no exception, but if you take a look at the display name, you just get an empty information. If you try to do the same with get domain name async or get principal name async to get the domain name and the principal of the current logged user, you will get an exception. But for the get first name and the get last name, if you try them, again, the information will be null. So this is another kind of API that provides properties to know which API you can use, which method or property you can use. And in that case, unfortunately, for a desktop app, even if the documentation, the MSDN documentation states that you can use it, yes, you can use it, but at runtime, you won't be able to do anything with it. The last one, let's break. The last one is, I would say, more interesting because the storage folder and the storage file are not supposed to be used by your desktop application. If you take a look at the documentation, so this is the one for application data. If we take a look at storage folder, so the storage folder class, And if we go down to the bottom, you will see that it's only for Windows Store application. So you are not expected to be able to use it. But you can. Yeah, you can use a storage folder and storage file in a desktop application. This is what I have done here. I have used the storage folder from the picture library, get the name of the folder, and I'm using the search, the power of the search in WinRT to get the files in this folder. So here I'm using the default query, which is the usual one where you get all the files in this specific folder. And if we run this one, I just clear, and just to let you see what's going on, when I'm clicking on storage, you can see that in my pictures I have 2 GIFs files, 1 JPEG and 1 PNG. And this is what I have in my picture library. You see, I have the 2.jpg, 2 Dilbert and 1 sample image. But what is interesting here is the fact that you can really leverage the power of WinRT, because with the kind of query you want to get, you don't have to change a complicated processing or a complicated code to iterate on all the subfolders. If there is a kind of library like this one where you can have links to different folders, then you just have to change the default query, like the order by name, and this one will dig into each different subfolder and return the list for each different subfolder. So here you can see that in the pictures, if I'm going back to my pictures, I have the camera, the 4 files, the camera rolls, and the NVIDIA Corporation, because on my pictures here, it's a library, and in my library I have my pictures with the camera roll and the screenshots, which is empty, and I have the public pictures where the NVIDIA Corporation for my graphic card are copied some files, some images. And with this single line, I can just get the list of all subfolders and sort it by name of the files. Very, very handy. This is the kind of API where you might really, or I should say, you should take the time to think about replacing your usual .NET code by WinRT code, because they are providing a higher level of API, which is much, much powerful. One last detail or caveat here for the storage folder and storage file. They are usable only for libraries. You can't access different part of your file system because it's protected by WinRT, even for a desktop application. Thanks for your attention. I really hope that now you have a better understanding of how you should see WinRT, like a unified Windows API for any kind of application. Bye bye, folks.